CLO1.4, summarize data using measures of central tendency, such as mean, median, mode, and using raw data and frequency distributions. Okay, I'm going to cut up this video into 3 sections. First, we'll talk about what is the mean, the median, and mode. These are called measures of center. We will do the mean, median, and mode from raw data, just a list of data. Then we will figure out how to find them from a frequency distribution, which is a table. And then lastly, we will do some word problems related to these topics. Okay, so let's start with finding the mean, median, and mode from raw data. Each of these 3 measurements are what we call measures of central tendency. You will probably have used the word average more than mean. And sometimes we'll use this symbol. It's a Greek letter mu. It kind of looks like a curly M. Or sometimes we will use this X with a line on top. And this is just equal to the sum. This symbol means sum. Add up all the data points and divide by the number of data points in your set. Okay, the next measure of center is called the median. And you can remember it is the middle number, it's the middle number when arranged from smallest to biggest. Okay, the last measure of central tendency is called the mode, and this is the most repeated data point. It is possible to have one mode. If there's only one, that is the most popular, the most common. It's possible to have no mode if nothing is repeated, and it's possible to have more than one mode if more than one data point is repeated the same amount of times. So we'll do examples of all 3 of these measures of center in the next slides. Okay, we'll start with the mean. The mean, remember from the last slide we talked about, it's the average. Sometimes they say numerical average or calculated average. It's an average that we're doing a calculation. We add all the data points and divide by the total number of data points that we added. One thing to remember, it is unique, meaning for any set of data, there is only one mean. We can only calculate the mean when our data is quantitative, numbers, and the mean can be positive or negative. It's just measuring the middle of the data. So if the data is negative, your mean is going to be negative. So let's do an example. Here we have some test scores, and they want us to find the mean. We can use this curly M to stand for mean, or we can use this X with the line over it. But basically, we will add up all the test scores and divide by how many items we just added, 1, 2, 3, 4. And then we will get a mean of 76.5. Okay, let's do some examples with the median. Remember, the median is the middle of a set of data. Sometimes it's called the positional average because it cuts the data in half. It finds the middle position. Half the data is below the median and half the data will be above the median. The median is also unique. There's only one median for every set of data. And again, the middle can be negative. If all the data you collected is negative, the median can be negative. And again, we can only do this when our data is quantitative, because we're lining things up from smallest to biggest, which you can only do with numbers. Let's do a few examples. So, find the median of this set of data. First thing we need to do is line them up from smallest to biggest. So 66, then 78, then there's another 78, then 80, and 82. So there are 1, 2, 3, 4, 5 pieces of data. So the middle one would be 78. This is the median for this data set. Now you might ask, well, what if there is an even number of data points? So example 2 has that situation. So we'll line them up 66, 78, 80, and 82. In this case, if we were to cut this data in half, there's not one number in the middle. So what we do is we take the 2 numbers that are in the middle and find the middle of the middle. So we find the average between those 2 numbers. 78 plus 80 divided by 2. In this case, the median would be 79. So it's possible that sometimes the median is not a number in the data set, or sometimes it is. Okay, lastly, we'll talk about the mode. You can remember the mode is the most repeated item in a data set. It's possible, if nothing is repeated, it's possible to have no mode. If there is one most popular item in the data set, most repeated, then there's one mode. And if there is a tie, then you can have more than one mode. So this is the one measure of center that is not unique, meaning there can be more than one mode for a data set. When we have qualitative data, that means word data, like what is your favorite color? The data we collected is in the form of words, then the only measure of center we can use is mode. So let's do some examples. All right, the first example, we have some test scores and we want to find the most popular, the most repeated test score. Looks to me like the mode in this case is 78. So this is a case where there is just one most popular item in that data set, one mode. Okay, let's look at the next set of data. Find the mode for this set of data. Well, looks like nothing is repeated. When nothing is repeated, you say there is no mode. Okay, let's look at the last one. All right, lots of things are repeated. This is repeated twice. This is repeated 3 times. This is repeated 3 times. So it looks to me like there is a tie for the most repeated. There are 2 modes in this case. The 2 most popular answers, because there is a tie, are 2 and 4. All right. So in summary, let's do a practical example and find the mean, median, and mode of these weekly temperatures for a city in Canada, Calgary. So firstly, the mean, if you remember, this is the calculated average or the numerical average. You add all and you divide by the number of items, or if we're going to write this in formal math, we will write the sum of all data points divided by the number of data points. So in this case, -7 plus -7 plus -4 plus -3 plus -3, and there are 5 data points. So we will get the mean. Also, we can use this symbol, either of those. The mean will be -4.8, and I assume this is degrees Celsius. It's cold in Canada. Okay, let's look at the median. So the median, as you hopefully remember, is the middle number, also called the positional average, the middle position. So we line them up from smallest to biggest, and luckily enough for us, they are already lined up from smallest to biggest. That's not common, but we're fortunate. And the middle number out of 5 data points would be -4. Half of the data is less than -4, half of the data is more than -4. Okay, lastly, we will look at the mode. The mode is the most repeated number. And I see that 2 different numbers are repeated twice. And so basically, in this case, we will have 2 modes. And the 2 modes are -7 and -3. All right, so those are our answers for this example. Okay, I want to do one more example because sometimes you will get an example that is a little more unusual in terms of the data you're collecting. I'll explain more. So we look at this example. Said I interviewed 10 students and asked them how many speeding tickets they received last year. Here were the answers. I've already arranged them from smallest to biggest. And you might notice that one of the answers is unusual compared to the rest. So when you have an item, a data point that you collected that is much bigger or much smaller than the rest of the data, this is called an extreme value. Sometimes it's also called an outlier. It means basically it lies far away, far outside from the range of the other data that we've collected. It can be very big or very small. So let's calculate the mean and the median and see how it might get affected by an extreme value. So you may remember for the mean, you just add up all of the x's, divide by the number of x's you added. So this is going to be a lot. I think that's, 92. All divided by, I believe it's 10 data points. And you end up getting that the mean is 10 speeding tickets. Okay, well, let's look at the median. Median is just the middle number. And fortunately for us, the numbers are already arranged from smallest to biggest. There are 10 numbers. So the middle is in between the 5th and the 6th number. Usually, when you have two middle numbers, you just take the middle of the middle, or the midpoint between them, in which case we're going to get that the median is 1. So this measure of center median is quite different than mean in this case. So now we can look down and where it says which measure is more appropriate. Well, they are very different, and the issue is that the mean is quite big because we had this one outlier, this one student who received so many speeding tickets that skews the mean to be much higher than the rest of the data. So in fact, when you have an extreme value, it's always better to use the median. Why? Because the mean is misleading. The mean gets skewed toward the outlier. So if I just said the mean speeding tickets for my 10 students was 10 speeding tickets, you would think the students were not very good drivers, when in fact 9 of the 10 students were great drivers, and we had one student who sort of ruined it for the rest of them. His 92 speeding tickets makes it seem like the average is, or like the center of the data is much higher than if we had used the median. So the median is more appropriate when we have an extreme value. Okay, so that was raw data, that was the basics. Now we're going to try to find the mean, median, and mode from a frequency distribution table. So in this example, we have Isabella, and she checked on her street where she lives to find how many parking spaces each house has. So the data she's collecting is the number of parking spaces, and the frequency represents how many houses had that number of parking spaces. So in this case, we do not have any raw data. We just are given the data already organized into a frequency distribution. So by the way, just to remind ourselves, how many houses were on that street? If we add up the frequency, the sum of the frequency is the total number of data points. It is, let's see, I think 55 houses on that street. So that's what we're working with. Now, if we had wanted to see this data as raw data, then we would have 15 data entries that each had one parking space. 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 15. Then we'd have 27 that had 2 parking spaces. Obviously, I can't write them all. It would take forever. This is why a lot of times for data, it's not practical to see all the raw data. It would take a really long time to list out all 55 pieces of data that she collected, and it would take a really long time to add them up one by one. So that's why we need another method to get the mean directly from a frequency table or frequency distribution. When we want to find the mean from a frequency table, it's also called the weighted mean. Why is it called weighted mean? Because it's not okay just to say, well, the data we collected was 1 or 2 or 3 or 4 parking spaces, so all we have to do is add 1 plus 2 plus 3 plus 4 and divide by 4. No, we can't do it that way because, for example, the one parking space, the weight of that, the number of answers we had was 15 people said that, and then 27 people said 2 parking spaces, so that's weighted more. So in fact, the way you find weighted mean from a frequency distribution is you multiply x times f. You'd say, okay, 1 plus 1 plus 1 plus 1 15 times, that's just 1 times 15. And then 2 plus 2 plus 2 plus 2, on and on, 27 times, that's just 2 times 27, and so on. So we'd multiply these. We would do, let me write it here where I have space. The mean in this case would be 1 times 15 plus 2 times 27 plus here 3 times 8 plus 4 times 5. And then you divide by the total number of data points, which we already calculated was 55. So we will get that the average number of parking spaces in front of each house is 2.05 parking spaces. So just in summary, if we wanted the fancy formula for weighted mean, you add up x times the frequency and you divide by, you can either say the number of data points, or you could say, I can erase that, we can say the sum of the frequencies. Now there's another way using your calculator that will be especially useful when we have very large tables. It just ends up going faster than doing the weighted mean all manually. So these are the 3 calculators our students tend to have in this course. Before we get started, I want to show you how to set up your calculator so that you can have an interface in your calculator that has a table like this, x and frequency. So the first thing I want you to press is Shift and then Mode. I think it's the same in all the calculators. It is. Shift and then Mode, and then you press the down arrow button. And when you press the down arrow button, you should see a menu that has the word Stat next to number 4. So press 4, and then after you do that, it says frequency on or off. Press 1 for on. So again, Shift, Mode, down, 4, 1, and that'll set it up so that when we enter into where I show you next, you'll see this frequency table, both x and frequency as a column. So now, if you want to enter this data into your calculator, here are the steps. For the first 2 types of calculators, these are the same. You'll press Mode 3.2. If you have this calculator, this third one, you'll press Menu 6.2. Either way, then, you should see the x and frequency table like this. And that's where you just enter your data. So you're going to just press, in this example, 1 equals, 2 equals, 3 equals, 4 equals, and that should enter all the data in the x column. Then you use your arrow buttons to move over, all these are the arrow buttons, to move over to the frequency column. Go up to the top of the frequency and type 15 equals, 27 equals, 8 equals, 5 equals. After you enter all your data, press the AC button, which is right here. It will seem like you erased everything, but you didn't. It's saved. So then to find the mean, you will press, for these first 2 calculators, Shift 4, I'm sorry, wrong. It is Shift 1, 4, 2. And when you press that, you will see x bar equals, and we get that same answer, 2.05. If you have this third calculator, you press the option button and then 2, and that will give you the same answer. Here is an example of a grouped frequency distribution, which we will find a lot of. We have an issue. Here is the data we collected. It's in a group, and here is the frequency. Now, if we were going to use our calculator, there's no way to enter a whole group of data into each row of the x. So what we have to do first is find the midpoint. So to find the midpoint of any row, what you do is you just add up the lower bound and the upper bound and divide by 2 to get the midpoint, which in this case is 72.5. So that's the first midpoint. And we continue to do that for each row. 79 plus 90 divided by 2, and we get 84.5. Okay, and we'll just continue to do that going down, but I notice that each of these increases by 12 each time. So I can shortcut it by just adding 12 to each one. And there we go. So now when we use our calculator, we're actually going to use this data to enter into our calculator. So if you remember the steps, first thing we press is mode 3.1. If you have the white calculator, you'll do option 6.1. You enter all the data into the frequency table. Then you press AC to save it. Then lastly, to find the mean, you will press Shift 142 for most of the calculators. For that white calculator, I'm sorry, this is not option, it's menu 6.1. And for the white calculator, you will press, when you're trying to find the mean, option 2. So I advise you pause the video right here, do that, press mode 3.1 or menu 6.1, and enter the data points 72.5 equals, 84.5 equals, 96.5 equals, all the way down. Then use your arrow buttons to go to the right and up to the top of the frequency column. Press 3 equals, 5 equals, 8 equals, 9 equals, 5 equals, then press AC, then press Shift 142, or for the white calculator, you can press Option 2, and you should end up getting a mean of 99.7 is what I got. All right, this next example is how to find the mode or the modal class, the most popular category in a frequency distribution. This is quite easy. So just remember that the data is the thing that we're trying to find the most popular class of, okay? The frequency just gives us a clue of how to find the answer. The answer is not found in the frequency, it just gives us a clue. So when we're talking about the modal class, we're talking about the most popular or the most common or the most repeated, okay? So what you want to do is you want to find the biggest frequency. The biggest frequency is the row which had the most answers or the most people answering that in that category. So we will look here. That's the biggest frequency. That means the most people, whatever we were measuring, I don't know if it's how fast people were driving, maybe the most people were driving in this category, 103 to 114. So we look to the left, you find the biggest frequency, you look to the left to find the modal class. So in this case, we would say the modal class is 103 to 114. Okay, so lastly, I will show you how to find the median class from a frequency distribution. Remember, median is the middle number when you line all the answers up from smallest to biggest. So now we have to take the frequency into consideration. So here's what we do. First step is we are going to create another column called cumulative frequency. And to create a cumulative frequency column, you start with the first frequency, 3. And we say, okay, the first 3 answers were in this row. Then we add the next frequency, 5. 3 plus 5 is 8. So the first 8 answers, or 8 people, or the 8th person, finishes in that row. Then we add the next frequency distribution, and we've got 16. So what this means is in this row, the 9th through the 16th person are standing there. So then 16 plus 9 is 25, and then 25 plus 5 is 30. And this last entry in a cumulative frequency distribution is always the nth, or the n. It tells you how many people were in the survey or in how many items were in the data set total. So if there are 30 items in the data set, remember we divide it by 2 to try to find the middle position. So the first 15 are in the first half, and then the last 15 are in the last half of the data. So in fact, the 15th position would be here, the 16th position would be here. These are the middle 2 positions, right? The first 15 is the position number 1 through 15, and the last 15 is position number 16 through 30. So the real question is, where is the 15th and 16th data point? Officially, the middle position of any number of data points is going to be the number of data points plus 1 divided by 2. In our example here, 30 plus 1 divided by 2. It says the middle position is the 15.5 data point, which again reinforces it's been between the 15th and the 16th data point. So we go ahead and we look at our cumulative frequency distribution and we see where that is. So this means the first 3 positions are in the first row. This means position 4 through 8. 4, 5, 6, 7, and 8 are in that row. This means position 9, 10, 11, 12, 13, 14, 15, 16. So we know the 15th and 16th position are in this row. So we will look to our left and say this class is the median class. And so what that means is half of the data were in that class or below, 91 to 102, half of the data were in that class or above. Okay, let's finish with a summary example. This is a frequency distribution. It's the amount spent in dirhams and the number of shoppers. So in order to find the mean, we will use our calculator. So first thing we do is we press mode 3.1, we enter all the data and we press AC, or if you have the white calculator, you press menu 6.1. But you will notice that we can't enter both of these numbers, so we must first find all the midpoints. You find the midpoints by adding and then dividing by 2. So let's make a column here for midpoint. And 100 plus 150 divided by 2 is 125. And to save time, I just filled all those different midpoints in. So this will become our X column, and this is our frequency column when we enter our data. So pause the video and do that now. And then you press Shift 142, or with the other calculator, Option 2, and you should get the mean. My calculator says 281.476, but for money we should always round to 2 decimal places. So 281.48 dirhams is the average. Okay, so the mean is 281.48. Now they're asking for the mode. The mode is the most popular or the most common category of spending. So the way you find the mode, as a reminder, is you're going to find the biggest frequency. So I see the biggest frequency is right there. And then we're going to look to the left. So the mode of this frequency distribution, or the modal class, would be between 350 and 400. Okay, now the last question is the median. This one's a little bit more difficult. The first thing we're going to do is create a third column called the cumulative frequency. So we start 12. 12 plus 23 is, 35. 35 plus 41 is 76. Plus 35 is 111. Plus 23 is 134. Plus 52 is 186. Plus 7 is 193. That is the total number of items in the data set. And the middle position is at n plus 1 over 2. So that's 193 plus 1 over 2. So the middle position is the 97th position. So we need to see where the 97th position is standing. Up to the 76th position is there. And this is up to the 111th position. So must be in here. And then we will look to the left and say the median class is between 250 and 300. So half the people spent between 250 and 300 or less, and half the people spent between 250 and 300 or more than that. That's the middle position. Okay, that's a summary of all of the measures of center from a frequency distribution. Okay, lastly, we are going to do some word problems involving the mean. And I cut them into 3 main types. So here's the first type. The first type of word problem has to do with weighted mean. Weighted mean, if you remember, is when they give us data points, but then they tell us either how frequently those data points happened or how much each of those data points is worth. And so this would be an example here where we have grades. You have an exam, a term paper, and a final exam, and they have different weights. So we can put the weights as the frequency column. So the exam that was 20% will go there, 30% is the weight for that second exam, and then 50% is the weight for the final exam. And here is the data. We got 83 on the first exam, 72, and then 90. So now to find the average, you can either use your calculator, which is mode 3.1, enter your data, press AC, and then press shift 142. Or we can do the weighted mean calculation where we multiply all of these and add them together. So we would do 83 times 20 plus 72 times 30 plus 90 times 50. And then we would add up all the weights. The sum of the frequency is 100. And then when we do that calculation, we would get the average. Either way, calculator or by calculation, we get the mean. The weighted mean in this case is 83.2. Let's look at the next example. It's similar. It says we've got the average age of a student who is 17 at the women's college, and the average age of students is 19 at the men's college. But then the question is, well, how many students did they use to calculate those averages? The number of students would be the weights or the frequency. So at the women's college, the average age was 17, and it looks like there were 900 students. And at the men's college, the average age was 19, and it looks like there were 1,100 students. Now, again, you could use your calculator to calculate this, or you could use the weighted mean formula. I forgot to write that. Let me go ahead and write that. You do the sum of x times the frequency divided by the sum of the frequency, which is the total number in the total number of items. So let's go ahead and we can do it the long way. You can use your calculator if you want by pressing mode 3.1, but we will do 17 times 900 plus 19 times 1,100, and then we will divide that by the sum of the frequencies, 900 plus 1,100. Or if you did it by your calculator, either way, we would get the same answer, which is 18.1 is the average age when we consider both of the data from both campuses. Okay, the next type of word problem that we will often see, I like to call missing data. And you'll see with the two questions I chose, they're quite similar, different specifics, but the way we do them is going to be quite similar. So let's read what we have. We have the average cost of 4 different brands of tea is 70 per kg. So they're telling us the average is 70, and they told us the price of 3 brands. So we'll call it B1 is 66, brand 2 is 74, brand 3 is 76, but we do not know the 4th brand. That's what is missing. So we want to find that out. So what we can do is we can do it either by algebra or by logic. I'll set up the algebra for you, but then I'm going to show you sort of the logic way that I like to do it. First of all, by algebra, we know the mean is the sum of all the data points divided by the number of data points. So in this case, it would be 66 plus 74 plus 76 plus, let's call this B for the brand. Okay, we don't know what it is, and we knew there were 1, 2, 3, 4. But we also know the average is 70. So it's just a simple algebra problem to solve for B. But I know some people don't like algebra, so let me show you the logical way I like to approach it. It ends up being the same steps as algebra. But in general, I want you to remember this. The sum of all the data is just going to be the number of data points you have times the average. Okay, so the number of data points we have is 4. The average is 70. So no matter what all these costs are, they're going to add up to 280. That's the sum. Well, since we have 3 of them, if we subtracted what we know from the sum, what we'd be left over is the one that's missing. So we'll subtract 66, subtract 74, subtract 76, and we will get that the missing brand costs 64 dirhams. Okay, let's look at the next one. It's quite similar, just a different set of circumstances, different set of examples. So here we've got a basketball player and he wants to score an average of 20 points per game. So they're telling us the average is 20 and it's 5 games. So we've got game 1 was 18, game 2 was 15, game 3 was 22, game 4 was 21, and we don't know game 5. We want to know what he should score on this 5th game in order to achieve that average. So we could set up the algebra problem, but I'm going to go straight to my logic steps because I find this the easiest way. I remember that the sum of all the data is just going to be the number of data points times the average. So the number of data points, there's 5 games. The average we want is 20. So we know the total number of points we want is going to be 100 points. Let's just go ahead and subtract what we already know. And what we have left over will be what we need in that final remaining game. And it turns out on game 5, this basketball player should score 24 points if he wants to have that average. Okay, the last type of word problem we will often see, I like to call it changed data. And that's where they tell us some information and they tell us the average, and then something about the data has changed, and we need to adjust for that. So let's look at the first one and write down what we know. It says the average age of a German football team, there's 11 players. So we know the N, the number of players is 11, and the average age is 31. And they say one player aged 44 is replaced by a young one aged 22, and we need a new average. So again, we could set up a complicated algebra formula, but I prefer to use logic and to start with what I know. So the sum is always going to be the number of data points times the average. So in this case, it's going to be 11 by 31. So all the ages are going to add up to 341. And then we'll see what changed. A player aged 44 is replaced. So he leaves the team. So we subtract his age from the total, and he's replaced. So a new one joins the team who is 22. So we're going to have a new sum in this case, and it will be 319. Now, how do we use that to answer the question? We want the new average. Well, we know the average formula is just the sum of the data divided by the total number. Well, we have a new sum. It's 319 divided by, it's still the same number of people in the football team, on the football team. One person left, a new person joined, so it's still divided by 11. So then the new average will be age 29, which makes sense just logically because an old player left and the average age was 31 and a young player came, so the average moved to be younger because of that young player joining. Okay, let's do the next one and see how similar it is. So we have a fitness club. The average weight, so they're saying the average weight is 65 kgs and there were 18 members. Okay, so again, let's start off and just work with what we know and then use logic. The sum of all the data is just the average times the number of data points, so 18 times 65. So if we put everybody on the same scale at that fitness club, we would get a total weight of 1170. But then it seems like something changes. One member who weighed 85 kgs, he changed his weight. So that weight is no longer his weight. We'll subtract it. He dropped down and became 72. So that's his new weight. So we will get a new sum in this case, and it will be 1157. But let's go up and answer the question. We want a new average for the group. So the average is always the sum of the data divided by the number of data points. We have a new sum, in this case, 1157. The number of members of the club seems is the same. Somebody left, not somebody left. Same guy, but he just dropped weight. So we still have the same number of people in the gym. We do our new calculation to find our new average weight, and we expect it to go down since this guy's weight dropped, and it goes down to approximately 64.3 kgs. Okay, so those are the very common, typical ways we might ask word problems related to the mean.